All right, here's your video for 5.9, which is talking about parallel and perpendicular lines. So we're going to review the different forms of linear equations. Okay, the first one is standard form, which is ax plus by equals c. Slope-intercept form is y equals mx plus b. And point-slope form, y minus y1 equals m times x minus x1. Now within each of these equations, we want to talk about what is the slope. So if I have an equation in standard form, the slope, which is m, the slope is going to be negative a over b. Okay, negative a over b. So if I solve ax plus by equals c, if I solve for y, watch what happens. The first thing I do is I subtract ax. Okay, and so then I have by equals c minus ax. And then I divide by b. So I get y equals c over b minus a over bx. So this looks like slope-intercept form. This is your m, negative a over b. So that's where that comes from. So if you have standard form, you can identify the slope by just taking the opposite of a and dividing by b. For slope-intercept form, that one's pretty easy. The slope is just the m, whatever's in front of the x. And the same thing for point-slope form. All right, so make sure we can identify slope from all three different equations. Now, if we have an equation that doesn't look like either of these, then we would need to rewrite it so that it did look like one of these, which rewriting it probably the easiest would be to put it in slope-intercept form. Okay, so parallel lines are, try to type this out here, lines that never intersect because they have the same slope. Okay, lines that never intersect because they have the same slope. So in order to identify parallel lines, we must know the slope. That's why the section above this was so important, so we know how to identify slope. All right, so what we're going to be doing here is we're going to identify if the following lines are parallel. Well, in order to know if they're parallel, we have to find the slope. Okay, because the parallel lines have the same slope. They have the same rise and run, which is why they never cross. So let's take a look at the first one. Y equals 2/3 x plus 8 and y equals negative 2/3 x minus 5. Well, these are both in slope-intercept form. So this m is 2/3 and this m is negative 2/3. Are those parallel? No, they are not. They are not parallel because they do not have the same slope. This line is going to be rising 2/3 and this one's going to be falling 2/3. So those are not parallel. Number 2. Y equals 5x plus 2 and negative 10x plus 2y equals 24. So this is in slope-intercept form and this is in standard form. So this one is easy. My m is 5. Okay, my m is 5 right here. Now this one, remember m equals negative a over b. Okay, so let's figure that out. What is my a? My a is negative 10. So what's negative 10? It's positive 10. Over b, what is my b? My b is 2. What is 10 divided by 2? It is 5. So these would be parallel. Now, if you wanted to, you could rewrite this equation in slope-intercept form. Negative 10x plus 2y equals 24. You could do plus 10x, then you could do 2y equals 24 plus 10x, then you could divide by 2 and divide by 2, and you could get y equals 12 plus 5x. But that's not necessary because we understand that the slope is going to be negative a over b, and that's all we're interested in. If I need the y-intercept, then I could do this. By the way, the y-intercept is going to be c over b. It's going to be 24 divided by 2. All right, so I'm going to erase that. Just want to show you that you could do this, but again, it's not necessary. If you know that the slope is going to be negative a over b. All right. The next one. Y equals 3x plus 2 and y minus 5 equals 3 times x minus 1. So this is slope-intercept and this is point slope. So here my m is 3 and here my m is 3. So those are parallel lines. Last one, I have standard form and I have slope-intercept form. So in this one, m is negative 1/2. And in this one, okay, what is a? Well, a is 1, right? There's an invisible 1 there in front of the x. So it's going to be negative 1 over b, which is 2. So these are also parallel. Now, you could also graph these lines and look and see what they looked like, but I need you to understand that just because two lines look parallel on a graph, that does not mean that they're parallel. You have to check the slope. All right, write an equation of a line parallel to y equals 3. Okay, so let's remember what y equals 3 looks like. So y equals 3 on a coordinate plane is going to be here. Y equals 3. So what's going to be parallel to that? Well, what's the slope of this line? The slope of this line is 0. M equals 0. So I need another equation that has a slope of 0. Well, how about y equals 5? Or y equals negative 3? Or y equals 0? Or y equals 6? Okay, it could be anything. Y equals any number where the slope is 0. All right, so then I want you to do these two and have them prepared in class, please. Write an equation of a line parallel to x equals negative 4. And then write two equations so that the lines are parallel. So like 1 through 4 up here. Each of these was two equations. Okay, I don't care what form your equations are in. I just need you to give me two equations that are parallel. All right, now let's talk about perpendicular lines. All right, perpendicular lines are lines that intersect to form a right angle, which is 90 degrees, with, because their slopes are negative reciprocals. The slope of one line multiplied by the other will equal negative 1. Okay, so lines that intersect to form a right angle, which is 90 degrees, because their slopes are negative reciprocals. The slope of one line multiplied by the other will equal negative 1. So, same thing applies for perpendicular lines. To identify perpendicular lines, you must know the slope. All right, let's talk about negative reciprocals for a moment. Negative reciprocals. Okay, we're talking about the slope here. So if I have a slope of 4, then the negative reciprocal of that is going to be negative 1 over 4. What is reciprocal? Reciprocal means when you flip the numerator and the denominator. Okay, we've used reciprocal when we multiplied or divided fractions. Okay, so we use reciprocals, right? 4 is the same as 4 over 1. So the reciprocal of that is 1/4, but I need to take the negative reciprocal, so I put a negative sign in front. All right, so what's the negative reciprocal of negative 2/3? Well, that would be positive 3 over 2. So when I multiply these two, I get -1. -2 times 3 is -6. 3 times 2 is 6, and -6 divided by 6 is -1. Okay? So if I have this slope and this slope, then they would be perpendicular. Same thing here. All right, so let's check this out. So y equals -4 and x equals 3. Interesting. We just talked about this, y equals -4. That's a zero slope, so that's going to look like this. And x equals 3 is an undefined slope, which is going to look like this, which is in fact going to create a 90-degree angle. So yes, they are perpendicular. Okay, so zero slope and undefined slope are always going to be perpendicular. So horizontal and vertical lines will always be perpendicular. All right, this one. This is in point slope form. My m equals 5. This one is in slope intercept form. Oh, well, it's supposed to be. I think I left off an equal sign there. So that's equals -1/5. So we're going to say m is -1/5. Are these negative reciprocals of each other? Yes. So this is going to be perpendicular. I would encourage you to try 3 and 4 on your own. Like pause the video and see if you can figure them out, and then start the video again and see if you did it right. Don't cheat. Pause the video. All right, so this equation, m equals 4, and over here, m equals 1/4. Now, these are reciprocals, but they are not negative. So this would not be perpendicular. Now, let's think about parallel. Are these parallel? No, they're not parallel because they don't have the same slope. So what does that mean if they're not parallel and they're not perpendicular? That means that they intersect somewhere, but not at a 90-degree angle. So these two lines would be neither parallel nor perpendicular. They intersect, but not at a 90-degree angle, okay? All lines are going to intersect unless they are parallel. Every line intersects unless they are parallel. So if they're not parallel, we know they intersect, but just not at a 90-degree angle. All right, last one. This is in standard form. So my m is going to be -3 over my b is -5, which actually is a positive slope because a negative divided by a negative is a positive. And then over here, this one's pretty easy. This is in point slope, so my m is -5/3. And so let's take a look. 3/5 and -5/3, that is indeed perpendicular. All right, write two equations so that the lines are neither parallel or perpendicular. I just gave you a hint to that. Okay, you need to do that before you come to class. I gave you a hint when I talked about number 3. All right, last section here, writing equations of parallel or perpendicular lines. So we want to write an equation for the line that passes through this point and is parallel to this. So this tells us what our slope is going to be. We want our slope to be 5 because we want it to be parallel to this, and this has a slope of 5. And we want to use the point 4, 5 because the line passes through that point. So we're going to use point slope form. Y minus 5 equals 5 times x minus 4. Remember, this is x1, y1. Okay, y minus y1 equals m times x minus x1. Now, this is what I'm asking for. Okay, you could stop there, but I just want to make sure you know how to put this in slope-intercept form. I can add this 5 to the back over here. So y equals 5 times x minus 4 plus 5. Notice the plus 5 goes outside the parentheses. So y equals 5x minus 20 plus 5. So y equals 5x. Negative 20 plus 5 is minus 15. Okay? All right, write an equation for the line that passes through 3, 2 and is perpendicular to y equals 3x minus 1. So if it's going to be perpendicular, then my slope needs to be -1/3. And it needs to go through the point 3, 2. So same thing, I'm going to use point slope form. Y minus 2 equals -1/3 times x minus 3. Add 2 to both sides. So y equals -1/3 times x minus 3 plus 2. Distribute. y equals negative 1/3 x. Negative 1/3 times negative 3. First of all, it's going to be a positive. 1 times 3 is 3. 3 times 1 is 1. 3 over 3 is 1. Plus 2. So y equals negative 1/3 x plus 3. Again, this would be sufficient for what I was asking, but it's really helpful if you can rewrite it in slope-intercept form so that you would know a little bit better about what the graph would look like. What do we know about this? We know that it's going to cross the y-intercept at 3, and we know it's going to go down 1 over 3. It's going to be a pretty flat line. It's not going to be very steep. Whereas this one's going to be pretty steep because the slope is 5, and it would start at negative 15 on the y-axis. It would cross the y-axis at negative 15. So that's how you do parallel and perpendicular lines. The key thing here is the slope, and we'll be doing some practice problems in class. See you then.